The heading we're under is trigonometric identities. Okay, trigonometric identities. Now let me help you understand what that means, right? Before I give you the nitty-gritty of how they work. Okay. Remember, trigonometry began in triangles. It began in triangles, but we saw that that definition was limited, right? You couldn't do angles that were not acute, and you couldn't do angles on weird numbers like 0 and 90 and so on, right? So we went away from triangles and we introduced another geometric figure. The unit circle, right? And we used the coordinates on the circumference of the unit circle as our definition for cos and sine. So instead of this thing, instead of just ratios, okay, we took that ratio idea and then we went to think about all of the little coordinates on different spots in the circumference of a unit circle. So we expanded our understanding. Now we've done the same thing with the functions individually. When you first meet sine, cos, and tan, they're always attached to an actual triangle with actual angles. So, you know, typical questions at the beginning are, use your calculator to evaluate sine of 55 degrees. But as we've already started to do, right, we have moved away from sine of an angle in a triangle to sine as a function, and you don't even know what the angle is. Or you're considering all possible angles on a graph, right? 0 to 360, minus 360 to 360, whatever. Now, trigonometric identities, right? They get at the idea that you move away from triangles to unit circle, you move away from angles to just the functions themselves, and then we start to develop all of this language around the trigonometric functions that are nothing to do with angles. Right? We don't even care what the angles are. We're just thinking about the functions. So this is another way of saying that the trigonometric functions all become their own language. Right? You can speak in terms of sines and coses and tans, and that's why a lot of this is difficult, because you're literally learning a new language. Okay? That's the context to understand trig identities. Trig identities, they're kind of like a cross between like your dictionary and like sort of, or a vocabulary or a grammar that helps you take the language of trigonometry and manipulate it. Maybe rephrase things in a way that's clearer or more succinct or more useful, that show you more insights, right? So they're what we can use to shift around the familiar sine, cos, and tan, cot, cosec, and sec into ways that are more useful to us, okay? But in order to, like, that's a path down there, right? But just like language is a tool for communication, okay? Before you get to, writing an essay or giving a speech, you've just got to learn what the words are. And you've got to learn how verbs and nouns and all that kind of thing fit together, okay? So for a little while, we will focus on identities of their own, but this is heading towards other things. We use identities for a purpose. Okay? So I'm going to show you a few different categories of trig identities, so you don't get them as like a long list of 20, 30 plus, like things you just have to memorize. They are like sort of grouped together in categories, which is why I have a few of these, okay? So, the first set of categories is the reciprocal identities. You actually already know these. The reciprocal identities. Right? And they are on this hexagon, okay? Now the hexagon helps you remember, in another way, not just looking at the third letter, it helps you remember what the reciprocal identities are. For instance, so we got this one, sine x, right? 1 over sine x, the reciprocal sine x, of course, is cosec, right? Now you can see that on the diagram because, here's my other color, and you can draw this on yours as well, that's why you'll need a few. If I go across this diagonal, like so, can you read what I've got here? Read what I've got here, right? I can say this in two different ways. I can say cosec x is 1 on sine x. Or because they're reciprocals, I can say sine x is 1 on cosec x. Does that make sense? So I can go across and I can read a reciprocal. So it's to, you'll see, it's to help me recognize that it's 1 divided by cosec. And I use the 1 for other things as well.
So
okay?
is hexagon like on the number plane somewhere?
No, it's just a tool to help you remember these identities that I'm teaching you. Okay? I can go another one. Let's go right across directly. Okay? So I can say tan x is 1 over cot x, or cot x is 1 over tan x. Does that make sense? So I have all these reciprocal ones. I'm not going to dwell on them because you know them already. On the same diagram, I'm going to tell you about the quotient identities. These come up less, but they're still very useful to know, and you can read them off the hexagon, okay? Instead of going across the hexagon, I'm going to go around the hexagon. And I can go either way. For example, the most obvious one is this one. See what I've done? I've gone around the edge, right? And sure enough, 10x is sine on cos. 10x is sine on cos. But that's not the only one. You can go all the way around. Let's have a go at this one. Let's see. Sine x equals cos x divided by cot x. You see that? Let's try that. Sine x, right? Well, actually, I'll just do it the other way. Cos x on cot. Tell me again, what's cot? What is cot?
1 on 10.
It's 1 on tan, which is cos on sine, isn't it? So this is cos over, need some brackets here, cos on sine. Okay, so you can see these are going to cancel, and this is on the denominator, so it's going to flip up to the top. It's sine, right? So I read this as sine is cos on cot. I can keep going. Cos is cot on cosec.
Oh my god.
Cot, sorry, I just read that. Cosec is sec on tan. And all the way, I'm back to the start, okay? You can also go in the opposite direction. Let's have a look at this one. Cos is sine on tan. Can you see that? It's exactly the same as this, but in reverse, okay? It's sine divided by sine on cos. Gives you cos, okay? So I can go around and around and around, or I can go directly across, and I'm going to get reciprocals or quotients. Is that okay? Yeah.